Have you ever paused to consider whether we're truly alone in the universe? What if everything we've known, all the principles of science and existence we hold dear, are only a fraction of a much larger, more terrifying truth? What if the James Webb Space Telescope, JWST, has finally begun to uncover evidence that turns everything upside down, proof that could show us we live inside a black hole? Welcome to a reality that might be far more complex than we ever imagined. Strap in as we take a deep dive into this groundbreaking discovery, one that will make you question everything you thought you knew about the universe, from the nature of time and space to the fundamental forces that govern reality. And it all begins with the enigma of black holes, the nightmare of black holes. Think of the black holes you've seen in sci-fi films. They're often depicted as swirling, ominous vortices that suck up everything in their path. Yet, even those nightmare-inducing portrayals don't quite capture the sheer terror of what black holes really are. They aren't just dark voids in space. They are unimaginably dense regions where the rules of physics as we understand them break down entirely. Imagine something as massive as a star, perhaps 10 or 20 times the size of our sun, collapsing into a space no bigger than a city like New York. The result is a region of space with a gravitational pull so intense that not even light, the fastest thing in the universe, can escape it. When we look at a black hole, we are essentially staring into the ultimate trap, a place where matter, light, and even time itself spiral into oblivion. Black holes have fascinated and horrified scientists for centuries. The idea of such dense objects trapping light itself was first hinted at in the 18th century, but it was Einstein's theory of general relativity that truly unlocked the mystery. According to this theory, when a massive star dies, it leaves behind a core so dense that gravity overwhelms all other forces, resulting in a black hole. But here's the catch. We can't directly see black holes because they emit no light. So how do we know they exist? We detect them by the way they warp the space around them, influencing the movement of nearby matter. When a black hole passes through a cloud of interstellar gas or gets too close to a star, it pulls in material in a process known as accretion. As the material spirals inward, it heats up and emits X-rays, which we can observe from Earth. Even though black holes are invisible, they leave behind these distinct clues. Yet, black holes don't just sit quietly, hidden in the darkness. They are active, ferocious forces of destruction and creation. When a star strays too close to a black hole, it's ripped apart by gravitational forces. The resulting tidal disruption sends out shock waves of energy, and sometimes the doomed star emits powerful gamma-ray bursts before it's consumed entirely. These violent processes can halt star formation in some areas of a galaxy while accelerating it in others. In this way, black holes can paradoxically act as both destroyers and creators within the universe. But what exactly are black holes, and how do they form? Picture the following scene. A star that has burned brightly for millions, if not billions, of years is reaching the end of its life. After exhausting its nuclear fuel, the star can no longer sustain its own mass. A cosmic implosion ensues, and the star collapses inward, releasing an unfathomable explosion called a supernova. This is the ultimate celestial event, a last gasp detonation before the star's death. In its aftermath, only the densest remains of the star are left behind. If these remnants are massive enough, they collapse under their own gravitational force to form a black hole. What makes this process even more unnerving is that time itself starts to behave strangely near a black hole. To an outside observer, time appears to slow down as you approach the event horizon, the point beyond which nothing can escape the black hole's gravity. It's as if the black hole warps the very fabric of time and space, pulling everything toward an infinite void. Sometimes, two black holes collide, merging into an even more monstrous entity. And in rare, catastrophic cases, a black hole might partner with a neutron star, the superdense core of a smaller, exploded star. Together, they form a colossal force that defies comprehension. Now, let's talk scale. Black holes come in two terrifying sizes: huge and unbelievably huge. The smaller ones, called stellar mass black holes, are born from stars and can be anywhere from 10 to 24 times the size of the Sun. The most unsettling fact? Astronomers estimate there could be millions of these black holes, lurking in our very own Milky Way galaxy alone. That's right, millions of black holes silently roaming, waiting to consume whatever strays into their path. But that's not the end of it. At the heart of large galaxies, including our own, lies something even more terrifying: supermassive black holes. These cosmic titans are millions, if not billions, of times larger than the Sun. The one in the center of the Milky Way, named Sagittarius A, is an invisible monster that swallows everything around it. Its gravitational force pulls at stars, planets, and clouds of interstellar gas, creating a swirling maelstrom of destruction. Famed physicist Stephen Hawking spent much of his career studying black holes. His theories proposed that these objects might not be the ultimate end of matter, but his ideas were often limited by the technological capabilities of his time. Enter the James Webb Space Telescope, JWST, a revolutionary tool poised to push the boundaries of our understanding of the cosmos. The James Webb Space Telescope. The JWST is no ordinary telescope. It is an engineering marvel, a symbol of what human ambition can achieve when driven by the desire to understand the mysteries of the universe. While its predecessor, the Hubble Space Telescope, served us well for decades, the JWST is designed to see even deeper into space, unlocking secrets that have remained hidden since the dawn of time. This $10 billion telescope is a joint project between NASA, the European Space Agency, and the Canadian Space Agency. Over 300 universities contributed to its development, and its launch was a breathtaking success. The risks were high. Any malfunction could have doomed the mission, but the reward was even greater. With a mission lifespan now expected to last over 2 decades, the JWST is about to change everything. Since its launch, the JWST has been hurtling through space at over 1 million miles away from Earth, locked in orbit around the Sun. It deployed a massive 5-layer sun shield and a giant mirror, carefully unfolding like a cosmic flower. After months of calibration and testing, the telescope is fully operational, and its first images have already stunned the world. The telescope's powerful sensors allow it to peer billions of years into the past, revealing the universe as it was in its infancy. The JWST will study galaxy formation, the birth of stars, and perhaps most excitingly, the hunt for exoplanets, worlds orbiting other stars that could harbor life. Its technology is so advanced that it can even analyze the atmospheres of these distant planets, helping scientists determine whether they could support life as we know it. But the JWST's most profound contribution may lie in its ability to answer one of the most fundamental questions in all of science. Are we alone in the universe? The dark secrets of the cosmos. One of the most spine-chilling discoveries the JWST has made is that of polycyclic aromatic hydrocarbons, PAHs, complex carbon-based molecules found near supermassive black holes in distant galaxies. PAHs are fascinating because they could be the building blocks of life itself, lurking in some of the most hostile environments in the universe. When ultraviolet radiation hits these PAHs, they emit a detectable infrared glow, clues that astronomers can use to track star formation and other cosmic phenomena. But here's where things get even stranger. Astrophysicist Ismael Garcia Bernard and his team at Oxford University used the JWST to study PAHs in the centers of 3 active galaxies. These galaxies are home to gigantic supermassive black holes. What they found was unnerving. Near the black holes, the PAHs were being transformed, twisted by the intense radiation into larger, electrically neutral versions of themselves. The smaller, charged PAHs had been obliterated entirely. It's as though the black hole's immense gravitational and radiative forces are warping the very fabric of matter itself. These larger PAHs, however, found shelter within dense clouds of gas, managing to survive the black hole's wrath. This discovery complicates things for astronomers, who rely on PAHs to track star formation. If these molecules are being destroyed or altered near black holes, it makes it much harder to understand how stars are born in such hostile environments. The oldest black hole. And just when you thought things couldn't get any more mind-bending, the JWST detected something even more terrifying. What could be the oldest black hole in the universe? This ancient cosmic behemoth is a supermassive black hole weighing 10 million times more than the Sun. It resides at the heart of a galaxy that formed a mere 570 million years after the Big Bang, during the infancy of the universe. This black hole is so ancient that its very existence is challenging everything we thought we knew about the formation of galaxies and black holes. How could something so massive exist so soon after the universe began? Theories of black hole formation are being rewritten as we speak. Are we living inside a black hole? Here's where things get truly wild. Some physicists are now contemplating a theory that may sound like pure science fiction. What if the universe itself is inside a black hole? The idea is both simple and terrifying. A black hole is, after all, a region of space where time and space themselves are warped to the point of no return. Inside the event horizon of a black hole, space-time becomes so twisted that all paths lead inward, toward a central singularity, an infinitely dense point. Now, imagine that what we perceive as the universe is actually the interior of a black hole in another, larger universe. From this perspective, the Big Bang, the birth of our universe, could have been the result of a massive black hole collapse in some higher dimensional space. The singularity at the heart of the black hole would then be the starting point of our universe. This theory, while speculative, aligns with the idea that black holes contain universes within them, pocket universes sealed off from their parent cosmos by an event horizon. If true, this means everything we know, the galaxies, the stars, even time itself, exists within a bubble, confined by the crushing gravity of a black hole. The JWST, with its ability to peer back to the very beginning of time, could help us uncover evidence for this mind-boggling theory. Could the telescope reveal the cosmic fingerprints of a black hole's event horizon? Or perhaps it will find data suggesting that our universe is just one of many, each contained within its own black hole in a vast multiverse. The unsettling conclusion. As the James Webb Space Telescope continues its mission, it's not just revealing beautiful images of distant galaxies and nebulas. It's peeling back the layers of the universe itself, exposing deeper, darker truths about the cosmos. Black holes, once seen as the ultimate destroyers, may hold the key to understanding the very nature of reality. Are we living inside a black hole? Could everything we know be confined within an event horizon, forever trapped by the laws of physics that we barely comprehend? The more we learn, the more questions arise, and the more we realize how little we truly know. The answers may be just on the horizon, as the JWST continues to unravel the mysteries of black holes and the universe they inhabit. One thing is certain: the discoveries it makes will challenge our understanding of the cosmos and force us to confront realities far stranger than we ever imagined. Brace yourself. The age of discovery is just beginning, and it's going to be more mind-blowing than we ever dreamed.